I am so excited to be here in Israel. This is the furthest east I've ever been in my life, and special experience for me. I'm going to give a talk called Stream Away the Weight, and it's a bit of a story on pending UI and how we can make it amazing. Before I get started, though, I'd like to invite everybody who's physically able and would like to join me to please stand. We need to wake up. I am still jet lagged, so I need this more than you do, but I'm also going to make you do it anyway. So put your arms out in front of you like this, and squat down, and come back up. Yeah, you know what this is. Exercise. These are called air squats. We're going to do 12 of these together, and I want you to count out loud with me. Ready? 1, 2, now you got to count 3, 4, 5, 6. Doesn't that feel great? 7, 8, 9. We're getting close. 10. Actually, this is so fun. Let's start over. 12. Okay. Stretch up over your head as high as you can, and then even higher than that, and then over one side, and over to the other. All right. That's great. You may sit down. Thank you. So that helps relieve my nerves a little bit, and it also helps the blood flow in your body, which your brain needs to be able to process new information and things. So this is important. This is my friend Ryan Florence. We were at a conference in Atlanta recently, and we went to Six Flags after the conference because, do I need a reason? It's Six Flags. And we went on a ride called Daredevil, which is a super, super fun. In fact, we went like an hour before close, so there was nobody there, no lines. We stayed on the ride twice in a row. They just let us go again. And this talk is going to be a bit of a ride where we have, and this is just the way that it feels developing software, right? You solve a problem, and then you discover a new problem, and you solve another problem. So it's just up and down, solving problems the whole way through. And that's what we're going to be doing today. And the end of the ride for us is React 18 streams, where we start with fire, and then the streams put the fire out to just make that metaphor go further. We're going to be using this app. How many of you kind of recognize this app at all? Okay, so I can see the people who've been to remix.run before, because this is the demo app that we show to demonstrate nested layout and different things like that. So we're going to be working on pending UI in this app, and we're going to, of course, be using Remix. I'm the Director of Developer Experience at Remix. And I used Remix to rewrite my own website, and I loved it so much that I decided to join the company because I just basically couldn't talk about anything else but Remix. If you follow me on Twitter, you know I tweet about 3 things: Remix, One Wheels, and Wordle, and that's all I tweet. So if you're interested in any of those subjects, then feel free to follow me on Twitter. Also, I always forget, but I do have a silly amount of Remix stickers. So if you're looking for Remix stickers, I put a bunch out there, or you can come find me. And please do come find me, because I love to chat with people and meet people in real life and things. So that's it. Those are my slides. My slides are done. The rest of this is all just live coding. So I've got the app running, or actually I don't, because I restarted my computer. So let me get the app running. And I want you to see one cool feature of Remix right now is how fast the dev server starts up. It's amazing. Webpack, you'd like start the server and then go to Twitter for the next 3 minutes, right? No, you don't do that here. And boom, it's up. That's nice, right? I like that. Yes, hooray! The age of slow builds and slow everything is over. We've got cooler tools these days. Thank you, ESBuild. Okay, so this is our app, and in particular, we're going to be working in the customer section of the app. Boy, that screen sure lightens up all your faces. I can see you all better. So we just have a to-do right here, and I am going to implement this UI to get us started. So this is in our Playground app is where we're working. And did my screen size change? Can you all see? Well, hold on a second. Can you all see that in the back? I think my screen size may have changed. Oh, okay, good. So we're working in this customer ID route. This is a route module that's responsible for this part of the UI. So, and I just realized I keep switching between light and dark mode. I'm going to switch the theme here to light. Is that better? No? Okay. It definitely got a reaction. Okay, that's better. Okay, so we're going to get the data from our server and our database into our UI. And to do that, we have this loader. In Remix, your loader runs only on the server, and so you can talk directly to the database. You can use private keys to make fetch requests to third parties, whatever you need to do. And we have this utility for making a response called JSON that comes from Remix Run Node. And that is a generic, so we're going to pass loader data to help us make sure that we're doing things properly here, which I've defined up here. And we're going to say customer info, thanks Copilot, is await get customer info. And then our invoice details is await get customer invoice details. Okay, so we're getting the information. These functions are calling directly to our database under the hood. And then on the client or in our UI, rather than this to-do stuff, we're going to use a hook from Remix called use loader data. And we'll type it as loader data so that we get a nice autocomplete. And now we have all of our customers. Okay, so that's great. You built it, you ship it, and you're feeling awesome, and then you find out, oh no, my production database is not as fast as my development database. And like for various other reasons, whatever the reasons may be, this actually ends up taking longer. So let's simulate that. And it will say that it's the invoice details that takes a particularly long time to resolve. So we're going to await a new promise, resolve, set timeout, resolve, and we'll say it's maybe a math.random times 1,000. So 1,000 milliseconds, but it's going to be at least 1,500 milliseconds. So it's anywhere between 1,500 and 2,500 milliseconds is how long it takes to get these invoices. That would be really bad, but that's the reality for us for some reason. So now if I hit refresh, it takes a second before it finally resolves, so that's a pain. If I click on any of these, I clicked it, and now it finally navigates over. You can see the URL updates instantly, but we don't actually get any update to the UI until the data is loaded, which is not awesome. And I know that all of you are excellent developers, and you would never ship anything that doesn't have some sort of pending UI. And so we are going to get to that. But before we do, let's talk about how we could actually make this faster. Because as awesome as pending UI is, it would be even better if you just didn't really need it. Like if things were super fast, like if I go to my invoices, that's crazy fast. I don't have any pending UI for that. So it'd be really nice if I could avoid pending UI for this. So a couple of things that we can do to make this faster. First of all, let's parallelize this. We don't need to have one go after the other. They don't depend on each other. So we're going to use await promise.all for both of these. Just grab those and stick them right there. And then grab both of these and stick that right there. And then thank Prettier, because that's amazing. Thank you, Prettier, for making my life so much easier. So now we can run them both at the same time. Unfortunately for us, this actually doesn't make too much of an impact, but that's just one thing that you should be thinking about is like, maybe I'm accessing my data in a suboptimal way and we could optimize things a little bit. The next thing that we can do, because we're using Remix, is Remix knows your data requirements just by looking at the URL. So we don't actually have to render anything to be able to start getting the data for where we're going. And so if we come over to the route that's responsible for rendering the list of links for all of these, we have a nav link for each one of these customers. Then we can say, hey, Remix, I want you to prefetch this when the user intends on clicking on that link. And because Remix knows where this link is going to go to, and because it knows the data requirements just by looking at the URL, it can actually start prefetching all of this data right away. And so if we come over here and I hover over Ocean Avenue for a second, and then I click, then it's instant, because in the background, all of this stuff has been being prefetched. Now, if I'm a user who's just like clicking all over the place, I'm not going to benefit too much from that. But most users are going to hover for maybe half a second, maybe only 200 milliseconds. Could be a very short while. But if I hover over all of them, now they're all prefetched and yeah, they're still pretty slow though. So we could improve this even further. But there are a couple of things that just as takeaways here is you want to make things fast. Now, I should have, even before all of this, before you do any of this stuff, your first thing that you're going to do when you find a performance problem is make your server faster. I think a lot of us are trying to shave off like 5 milliseconds and 6 milliseconds off of our rendering time in our whatever UI library we're using. And that's great. Feel free to optimize that. But for a lot of the experience that I have, you can get a way bigger performance improvement by speeding up the server first. So optimize your server. So it shouldn't take a second and a half to load this data. Make it faster. Like, in fact, please just don't ever do this, and then all your problems are gone, right? But that's the first thing that you do. Then you can think about how you're accessing your data, optimize that, and then also prefetching if you are using a framework that supports that, which Remix does out of the box. It's really nice and easy. Okay, so sometimes you might be able to cache efficiently. So there is the capability in Remix to specify some headers on this response, and there's a cache control header that the browser understands, and we can say max age is maybe even just 10 seconds. Like maybe that's all that we can go for, maybe 60 seconds. We're going to cache it for a minute. Yeah, Hessadders. Thank you. This is mob programming with 1,000 people. Okay, so then if we go to these different pieces of the UI, that will be cached and instantly available. This with the cache header and the max age directive, that only applies to the user's browser, and so it's not going to be a shared cache header, so your server's going to get hit by every single user. But if you've got a CDN, then you can do s-max age. I don't know why they didn't just keep the dash, but that's what it is. And now it can be shared on the CDN. Now, there are a lot of situations where this doesn't work. Like maybe there's just way too much custom user data or something like that. And so you can't share the cache because every user is going to get a different experience. So there's also a vary header where you can, I can't remember what this one is. We're actually not going to implement the entire thing. I think it's cookie. And so you can vary it based on the user. But as soon as you do that, most CDNs are like, no, I'm not going to save every single piece of data for every single user in your app. No thanks. So there are situations where that's just not going to work very well for you. And so what we can do instead, and I'm going to skip over this bit because we don't have a ton of time, but we can implement some caching on our server. And so we're using this package called Lru Cache. That's least, what is that called? Or last recently used. Yes, thank you. So the Lru Cache, and it just lives in memory, so this isn't going to work in a serverless environment very well. But it will work for us because we're just doing a long-running server. And we just configure LRU for, hey, I'm okay with sending stale values. Here's how long my cache value should live, so 5 seconds really. It all just kind of depends on the use cases here. We have a maximum of 1,000 items. And so now I can click on each one of these, get them all preloaded in the server, and now it's crazy fast. But again, sometimes you just can't do this, right? Sometimes you cannot cache everything. Maybe it's an expensive calculation, or maybe there's just, we're talking about tweets, and there are gajillions of tweets. I don't know. I don't have any reference for that, but gajillions sounds about right. Sometimes caching just is not a reasonable thing at the scale that you're operating under. And sometimes it might be, even if you do have gajillions of things. But we're going to skip the caching thing. We're not going to do caching. And instead, we're going to talk about how to make this UI pending state better. The other thing is, even if you have really great caching support and things are working nicely, there's one thing about this whole experience that you have absolutely zero control over, and that is the user's network. So this is kind of a unique thing about the web, is that, and I suppose mobile has the same problem for apps that have that a centralized server. We have to worry about this network, and it's a huge pain because we don't have any control over that. Man, I got in the wrong business or something. No, I didn't. I love this business, but we need to provide a pending UI. Basically, always. You always need to think about how do I demonstrate to the user that I am responding to what they have done. You need to give the user some feedback. And so in Remix, what I want to do is I'm going to stick a spinner right next to our logo. That's what the designer said. That's our pending UI for what this is going to, what we want this to look like. And so that logo is right here, and we'll just bring in the spinner. We'll set visible to true, just to make sure that we can see what that looks like. There it is. It's kind of fun. Whee! And so we just need to determine when do I show that. And because Remix is managing our transitions between pages, we're going to hook into a hook from Remix, not the one from React. Use transition from React came second. We shipped first. But they also intended to ship, and use transition was a thing, experimental for a long time. So yeah, we were wrong. We'll probably have to change it. I don't know. Maybe we won't. Just make sure you don't pull it from React, because that's a very different thing. So we get our transition object that has all the state about the transitions that are happening on the page. And so we can determine whether we want to show the spinner based on transition.state is not equal to idle. So if it's loading or there's a submission happening, then we want to show the spinner. And here we go. Once that finally finishes reloading, then we get our spinner. And so we get at least some sort of feedback to the user when they're transitioning. It's still not fast. It's still really annoying. We do still have prefetching. So if I hover over this for a second and then click, then it transitions instantly, and that's nice. Now, one thing that I just want to call out when we're talking about spinners and loading states is that you really want to avoid a flash of loading state. So let's take a scenario where the whole network request, well, actually, first I'll say that we avoid that from the start. Over here, you see there's no flash of loading state because I have a animation delay just via CSS that says don't show the spinner in the first 100 milliseconds. Because if it responds in 100 milliseconds, the user's not going to perceive that. It's fine. However, let's say that the whole experience takes 150 milliseconds. So now they see a flash of the spinner for 50 milliseconds. I think that's ridiculous. I don't like that at all. And what I used to do when I was back in my AngularJS days is I would just slow down the request so that it was always at least 300 milliseconds, so that the spinner wouldn't like flash away. I made it so that if it was less than 300 milliseconds, I wouldn't show any spinner. But if it was more, then I'd make it take like 500 milliseconds or something, which I think is honestly, frankly, a better user experience than a flash of loading state. But we've got something even better, and that is a handy hook called useSpinDelay. Interestingly, this was built for my website by Stefan, and I can't pronounce his last name. I'm sorry, Stefan. But he built this for my global spinner on my site. And useSpinDelay just takes a Boolean like this, and then you can configure it. It has some good defaults, but I'll just show you. It has a delay before we actually show the spinner. We'll say that's, I don't know, 200 milliseconds, and a min duration of 300 milliseconds. So what this is saying is, if this Boolean is true for at least 200 milliseconds, then I will make sure it remains true for an additional 300 milliseconds. Okay, that's what that's saying. So now, with that in place, I actually don't have a demo for this, but just believe me when I say that the spinner is going to operate exactly the way that we want it to for this sort of scenario. So when you're building your pending states, make sure that you're not going to show a flash of loading state, because that's just, nobody likes that. I don't like that. Do you like that? You do? I was just making that up. Nobody said that. Okay, great. So we've got a loading state. Now, I think that having a loading state up in the corner here is not like the best. It's not my favorite thing, right? I would actually prefer to have a loading state over here. Like, this is the part of the UI that's changing. if you click here, you may not notice the global pending state here, right? And that's why like sometimes we put a bar that goes all the way across, and so it's like really obvious what's going on. On my website, I have this little thing that pops up. You might see it sometimes. And so we could make it more obvious, or we could just make the loading state a little bit nicer with some sort of skeleton UI. And so we're going to go to the parent component that's responsible for rendering this outlet. So this is where we render that list of links, and this outlet is what's being rendered right here. So the parent component is this thing that's responsible for these links, and then it says, if I have any children in the URL segment, that this is where they go. And so what we can do is we say, hey, if we're transitioning between different customers, then instead of showing the outlet, I'll just show a skeleton UI, and then we can get some of that pending UI there too. So right up here, I'm going to take this same stuff, and we're going to paste it right here. So it's the same idea. We're still using use transition from remix and use spin delay. And then instead of show spinner, I'm going to call this show skeleton, except I'm going to capitalize or include the S. It doesn't actually matter as long as I'm consistent, but like if you're reading it later, you'd be really confused. So we're going to spell it correctly. And now with this show skeleton in place, I can come down here, and I just happen to have a customer skeleton component all ready and prepared. Wouldn't that be nice if you're just like coding and you're like, oh yeah, somebody already made that all the time. That would be sweet. But this takes a name. We'll just call it loading. And an email, loading. Gotta spell it right or your users are gonna ask questions. Okay, so we've got our, when we are transitioning, we're gonna show a skeleton. And then when we're not transitioning, we'll show the outlet. So now I can go here and we get that loading. And that experience is way better, right? I don't have to look up here, and then I still get my prefetching. So if I'm hovering over here for a second, it's all prefetched, and boom, it shows up right away. So there's no sort of flash of loading state or anything like that. So I think that's a pretty nice experience, but what's really interesting here is because the parent is the one that's rendering out the skeleton UI, the parent already has the email and the name for the customer because it had to get that information for this list anyway. And so because we have that, we can actually make our skeleton UI even better by providing those. And fun fact, the Web History API has a capability for a one page to send data to the next page. And it's just called state. And React Router, which Remix uses, has an API for passing that state along, just called state on the link. And so we're going to send the customer that we clicked on, so the customer that we're going to when we click on this link, via state. And then our transition exposes that via the location. And so we can say if the transition location exists and it has state, then we're going to get our loading, here let's say our loading customer, which is a type of the customers at number. So it's one of these, or it's undefined. Then we can say loading customer is the transition. Yep, that's right, Copilot. Thank you. Here, and let's just make TypeScript happy for now. You're all better than I am at TypeScript, but we're just going to guess that as an E for right now. Okay, so now we have the loading customer, and so down here we can say if we want to show the skeleton and we've got a loading customer, then we will say loading customer.name and loading customer.email. So now our skeleton UI is actually pretty good now. So we just click and boom, there's our loading customer. And so now it just seems like we're only showing loading in the invoice details, which is nice. So you can actually get pretty far with a skeleton UI if you can give as much information as you have at the moment that you have it. This is actually similar to optimistic UI for page transitions a little bit. However, we're still not in an awesome place because if I go to my invoices page and then go to customers, then I've got my global spinner. I can't transition instantly right? Because I'm still waiting for the data on that page. Because my parent route was the one that was responsible for rendering the skeleton UI, and the parent route isn't on the page at the time I make this transition. Cool thing is, though, that this is also prefetched, and so if I hover over for it for a second, then it will transition instantly. So you still get your prefetching and stuff, but this is that part of the roller coaster where we're down again. And like, I'm not sure. I don't know. Maybe I should invert that metaphor, because I think the down part is the fun part, right? It's the part you go up. You're like, this is boring, unless you do a loop. Maybe the metaphor is breaking down a little bit. But we want to make this experience better. Now, and actually, if your boss came to you and was like, hey, this is garbage, I cannot have this, I must have that loading, like, why can't we just have this loading state here? And the other thing is, if we go to a brand new tab and we go to a specific customer right from the start, then we're waiting here. I mean, it's a nice picture, but that's not cool. I don't want to have to wait for that. And so this is what we normally do as React developers. And maybe you would have done this from the very start. You're like, I'm not going to server render that. I will just server render the loading state, and then on the client, I will go fetch my stuff. And that's pretty much the status quo for what we're doing now. And I don't want to take the time to code all that out right now, so we're going to just skip straight to it, except what number am I on? I don't know. Yeah, 9. That is not a space. There we go. Okay, so I'll just show you what magic. Wouldn't that be nice if we had a little command that says, do my work for me? Yeah, that'd be, I mean, maybe one day, right? Copilot's pretty impressive. Okay, so what I did here is we're now on in the code for this part of the UI. And in my customer route, I said, here's my loader data, but I do not want to have to wait for all the customer invoice stuff. So I removed that from my loader. My loader does no longer return that for the initial page. And so now we come down here, and we no longer get the invoice details from the loader data. We're actually getting it from this thing called useFetcher. And useFetcher is another feature of Remix that allows you to do client-side fetching or imperative mutations or declarative ones as well. The useFetcher is basically a way to make a fetch request that doesn't involve a navigation. So you use it a lot. You'd use this for a tweet like. You'd use it for a combo box that the user typing in, whatever, like all the typical API things that you think of when you think of web apps. So we're going to use it in a use effect with this load invoice details to make a request to go get the invoice details. And with that, then we have the experience that our boss came to us wanting, is we get to transition instantly. And then we just show that interstitial loading page. So that's good, but I've got a couple of problems with this. And we also get it an instant load for this. So we solved that problem. But this is the part where you're doing like a corkscrew or you're doing a helix or something. You're like, that was great, but actually, no, it was not great. Because if we take a look at what the network tab is doing now, and we go to our invoices. Here, let's not slow this down. We don't need to slow that down. And now I'm going to hover over customers. We're going to do that prefetch. And then we're going to click. And I didn't get the prefetch. That's no good, right? Because we can't prefetch this because it's not happening until we render. We might not even have the code to get this stuff. And like I said, this is kind of the status quo for most React applications, is you don't fetch until you render. And that's not great. But we do it for good reasons. We want to co-locate our data requirements with the code that requires it. We want to give that loading experience because we have a slow backend and we just have to deal with that. But wouldn't it be cool if we could get that loading experience and we could prefetch it? We wouldn't have to like request it inside of the component. We wouldn't have to wait until we render before we can go and get that data. Sure would. So we're going to do that. I'm going to get rid of this. We're going back to our regular skeletons, no client-side stuff. So we've got this problem again where we can go from invoices to customers and we're waiting and we hate that. And we're going to say, hey, boss, I'm going to revert what I did because Kent just taught me about React 18 streaming with Remix and it's great. And we're going to do that instead, right? That's what you're going to say. And the way that this works is Remix has a new API that's coming out in like a couple weeks. that you're just going to love. And it's called the Deferred API. So instead of JSON, we're going to use a fancy new function called Deferred. It's still a utility that can return JSON. So far, nothing has changed in the behavior of what we're doing. But we're also going to make our types a little bit happier by saying this is a deferrable. So our invoice details are deferrable. Now, TypeScript is going to yell at us down here and say, hey, this data invoice details is deferrable. That means it might not be here yet. And so what we're going to do instead is use a component called deferrable, deferred. And our value will be data.invoice details. And then inside of this, we're bringing back render props. Yeah. Remember those? I actually thought they were pretty great. But hooks came around and I'm like, yeah, we don't really need those very much, but check this out. So now we have our invoice details that comes from our deferred. And deferred also needs to know what we want to show when we're still loading. So we're going to have our invoice details fallback right there. Okay, cool. Let me make sure. I think that I got everything. Oh, right. One last thing. We do not want to wait, right? That's the whole object here. Is like we just want to wait for the stuff that is fast. We're going to defer the stuff that is slow. And so I'm going to change this a bit. We'll take this and put that with an await. And then we'll take this and not await that. And that is the magic sauce. So this is just the way JavaScript works. Remix is going to call our loader, and it's going to await. It's going to await our loader. Our loader is awaiting the customer info, but it's firing off that request to go get the customer invoice details on the server on that initial render, or when we're making this loader request on the client as a client transition. It happens right away. And then Remix says, oh, okay, sweet. So this is just a customer info. So I'll just, it's just an object. It's nothing fancy, just a customer info object. And then invoice details, it says, oh, that's a promise. Okay, so I will just send what I have, and then we'll stream in the results of this promise when it's ready. And thank you so much, React Streaming, for making this possible. It's so, so cool. And that's it. So we come over here, and we get our nice transition, just like we had before. We also get prefetching, and we get the experience that our boss wanted in the first place. We get the instant load into our loading state, and we didn't have to change a silly amount of our code. And watch this. Let's say that somebody really, really wanted to, we wanted to just test what it would be like to going back to not deferring and just waiting for the requests or for our invoice details. So having no loading spinners or states or whatever. That's it. And now it does what it used to do from the very start. Now we're waiting, and it server renders. So you want to do, maybe yours doesn't take a full second and a half. You're trying to decide, is it better to show the loading state, or is it better to just wait? You can A/B test this. Check this out. We're going to just skip ahead to 11. So you can make some sort of function that will determine whether or not you should defer it. And if you think you should defer it, then you will give the promise. Otherwise, you will await that promise. And so this function could say, hey, this customer, their data is really fast for some reason. Maybe you're integrating with their API, and that customer just has it together. So we're not going to defer that one. We'll just wait for them. Maybe this user is in an experiment bucket that says they're really patient, and they'd rather wait than see a loading spinner. Anything that you want. This is huge. Try to do this with your current framework that you're using. I guess if it's not Remix. And let me know how it goes, because it's not going to go well. This is great. And so now let's say that I just made the backend fast for Ocean Avenue. And so we can say, nope, we're not deferring Ocean Avenue because it's fast. They've got it together. But we're going to defer everybody else. This is huge. Yeah. So I'm really, really super excited about this. And of course, we can add in the cache control headers. You could do stale while revalidate if you had a CDN. Browsers don't support this out of the box, but lots of CDNs support this. So if that's something that you can do, this will still work with that. It still works with prefetching because it's just HTTP. Also, it's magic. Also, it's just code, but it feels like magic. It's amazing. So just to wrap up, as a review, when you run into a situation that's really slow, try to make your backend fast first. Shaving off like 5 milliseconds off of your rendering time is great. 5 milliseconds, yeah, if your rendering takes 5 seconds, you've got big problems. But if it's shaving off 5 milliseconds is awesome. But shaving off like 200 milliseconds off of your backend requests, yeah, that's even better. So optimize for that. Look for ways you can optimize the way that you're fetching data. Remix actually helps with this a lot because we move everything over to the server anyway. And so if you're thinking, oh, well, how I optimize my data is I don't request more data than I need, so I'm going to just use GraphQL. That's awesome. You can continue to use GraphQL, but Remix moves all of your data fetching to the server anyway, so it doesn't actually matter. You're not sending more data than you need to anyway. But yeah, you can make sure that you're parallelizing things, make sure that you're prefetching those things that are particularly slow. And then look forward to deferred. And if you want more of an explanation of like how is this working? Like how does it make it so fast? Then Ryan gave a great talk at Reactathon, not the conference we went to the roller coasters together actually, but it was awesome, titled When to Fetch, and you can find that on YouTube. My last slide has the location of my slides. It's just on GitHub, so you can find that link easier later. I just have one last thing I want to say. You are amazing.